Next chapter, chapter 12, is discriminant analysis. We're going to look at two different libraries. They both do the same thing, discriminant analysis, but they produce results in slightly different format. It's pretty straightforward, so we will be calculating probabilities or propensities for the classes and then determine classification. So let's start with setting up our default path to the default folder. Yeah, so run that. Then we set up the libraries that we need. Okay, we're going to use caret for confusion matrix, and we are not going to do lift charts, but if you want to do lift charts, then you would run the gains library. And these are the two discriminant analysis libraries that we need. Discriminer and then mass. Okay, so we're going to first use LinDA, linear discriminant analysis, from discriminer library. So first let's read the data. We're going to use the movers data. So we'll call it movers df. Okay, read.csv, writing movers dot csv. Okay. All right, then we will run the discriminant analysis, and let's go ahead and save the results in movers.da, discriminant analysis. So we're going to use linDA. Then we specify two things. We provide the predictor variables first and then the target variables. So predictor variables are the first two columns. So we can say movers.df, all the rows, and then 1 to 2 columns. And then movers.df, ownership is the target. So you run that, and then you have the movers DA. Okay, so we have the classification, the scores, and the bare bones confusion matrix. Okay, all of that are generated. Of course, if you have a validation set, then you will run predict to get the predicted scores for the validation set, which we will see in the next example. So now we can examine. Okay, so what we have here, we have the scores. So that will give you the discriminant function scores for the two classes. Then we have movers DA, mover DA. Okay, so if you take classification, and then that will give you the classification that we have for each column. And then if you look at mover.da functions, so it will give you the function of the two discriminant functions. Okay, so write that. Now if you want propensity, so we don't have propensity in the results, so we have to calculate that. So you can call propensity, and let's say we want propensity for the owner, right? Now we have to calculate that based on the scores. So we already have the scores here, mover.da scores. Okay, scores has two columns, non-owner and owner. So we want the propensity for owner. So we need to use the exponential function. So the formula is in the textbook. Yeah. So here is the formula, and we have two classes. So the class of interest, e to the power of the discriminant function value for owner. Okay, in the denominator, then you'll have the sum of the exponent e to the power of the non-owner plus e to the power of the owner discriminant functions. So we need to set that up here. So you have exp, that's your exponential function, and then we get mover.da scores, right? And remember, it is in the second column. So if we want to calculate this for each and every row, and we want the second column, so that's your e to the power of the discriminant function for owner, and we divide by the sum. So you have to do exp again, owner mover dot da scores for the first one. Okay, so then exp mover.da scores the second one. So the first and the second sum, that goes in the denominator, and then the owner part, that goes in the numerator. So run that. So then we get the propensities for owner. Okay, and then we will combine these results into a data frame, right? So movers dot results dot df, and we put that in a data frame. Okay, and the first column is the actual. So okay, actual equal to, so when you use data frames, you give the name of the column and then what that column should consist of. So actual, we want movers dot df ownership, right? So that's what we want for the first column, and say we want predicted as the name of the second column. Okay, and we want to put the classification in there. So that will be mover dot da classification, right? And then say we want the scores, the discriminant scores, and the discriminant scores already has non-owner as the column names. So all we have to do is we don't need to give names. So mover DA scores. So that's going to bring in the two column of discriminant function scores. And then finally, let's say we want the probability. Okay. Probability hyphen owner equal to the propensity that we computed, propensity dot owner. Okay, you run that, and here we have the results. So actual, predicted, okay, the discriminant scores for owner and non-owner and owner, and the propensity for owner. Okay. So now once we have this, then we can run the confusion matrix. Of course, this barebone confusion matrix is already available in mover DA confusion. Right? When you do that, you get the bare bones, just the confusion matrix. But if you want more extended version, we use that from Caret. So confusion matrix, predicted class, and then the actual class. So predicted class is in movers.results.df. We have the predicted, right? And then we have movers.results.df actual. Okay, and we want these to be as factors. Okay, if you run it as is, so you're going to get an error. So we have to say as factor that one, and then as factor for the second one also, and you run that, then you get your confusion matrix, and with the non-owner as the positive class. We want to identify the non-owners of writing mover. Okay, but if you want the other way around, then you have to specify positive equal to the other one.